Hello, this is a video that's going to go over the quick check for 6.12c for proportional relationships. This was about determining whether or not a proportional relationship exists while looking at a ratio table, like in number 2 and in number 3, or looking at a graph, like in number 4. Also, from words without a table or from a graph, that we want to see if there's a proportional relationship. Um, so in number 1, I guess we'll jump right into this. Miss Thompson asked her students if they're soccer fans, and they answer yes or no. Of these students that were asked, 20 say yes and 5 say no. Describe as many relationships as you can about those who are soccer fans and those who are not. So I would just jot down a quick table here, and you can do a vertical one or a horizontal table. They would say the same things. But basically, that 20 people said yes, 5 people say no. We want to describe some relationships between how many people said yes and how many people said no. Um, if I had a ratio table, we could say yes and no. I'm going to put this one at the end because what I'm going to do is actually simplify this. Um, 20 and 5 have something in common. 20 is the same as 5 times 4, and 5 is the same as 5 times 1. Well, what they have in common is this 5. So if we divide by that common factor, we could simplify this to find the unit rate. It would give us a unit rate. It's not always going to give you a unit rate, but it'll give you the most simplified version of that ratio. Actually, this is not 5 to 1. It would be 4 to 1 because we're dividing by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. Then we could count by 4s and count by 1s to make an equivalent ratio table that is proportional, because for every 4 people that say yes, 1 person says no. And that works with 8 to 2. That would be 4 yeses and 1 no, and then 4 yeses and 1 no. 12 to 3, 16 to 4, and 20 to 5 as well all have 4 yeses for every 1 no. So I could say that there's a 20 to 5 relationship between yes and no. There's a 4 to 1, an 8 to 2, a 12 to 3, and a 16 to 4. I don't know about expanding them, where if you were to have said 40 to 10, if that would be technically correct or not. I'd have to look into that. But I would say that these ones definitely describe the situation. Okay, so now looking at number 2, Jackson and Carlos were running around a track. They started running at the same time. When Jackson had run 9 laps, Carlos had run 3 laps. The table shows the laps Jackson and Carlos completed. So when Jackson ran 9, Carlos ran 3. If Jackson ran 9 more, Carlos runs 3 more. If Jackson runs 9 more, Carlos runs 3 more. So this looks like it's counting by 3s, just something that I noticed. This looks like it's counting by 9s. And every time it goes up by 9, Carlos goes up by a proportional rate of 3. So the other thing I noticed is that Jackson always runs 3 times more than Carlos. That if you were to take Carlos's laps and multiply it by 3, you always get the number of laps that Jackson runs. So that's interesting that there's a common rule between each pair of corresponding values. Let's see if the unit rate is the same for each. So if we were to take, we want to know how many laps does Jackson run per lap that Carlos runs. So we want to know Jackson per Carlos, so laps. So if it's 9 per 3, that equals 3 laps per 1 Carlos lap. If we look at 18 divided by 6, the number of laps that Carlos runs, we get that it is 3 laps per 1 lap that Carlos runs. And the last one, just to make sure that this is proportional all the way through, if we divide the last 2 values, it equals 3 laps per 1 lap that Carlos runs. So since we get the same unit rate for each pair of corresponding values, which would be like a pair of corresponding values would be the number 9 and the number 3. Because when Jackson runs 9, Carlos runs 3. Another pair of corresponding values would be 18 and 6, because when Jackson runs 18 laps, Carlos runs 6. So those are corresponding values. You would not say that 27 and 3 are corresponding values, because when Jackson runs 27 laps, Carlos doesn't run 3, Carlos runs 9. So those are the corresponding values. The 9 and the 27 are corresponding. And there is an equivalent ratio between each pair of corresponding values. There's an equivalent ratio. This ratio, and this ratio all equal 3. So it's proportional, because to be proportional, you need pairs of corresponding values between, or pairs of equivalent ratios between each pair of corresponding values. So yes, a proportional relationship does exist. Explain your reasoning. I would say because the pairs of corresponding values make equivalent ratios, or that the unit rate is constant through all of the pairs. Because they're pairs because we're comparing two things with a ratio. So we'll always have a pair, one thing compared to another thing. All right, so we are going to look at another ratio table and determine if it is proportional. So it's asking the same question: does a proportional relationship exist between the time spent on a cell phone and the cost of Wi-Fi? So this one, does a proportional relationship exist? Well, let's use the same strategies as before. So we want to know if a proportional relationship does exist, then there will be the same unit rate for each pair. So the unit rate that I would be interested in to know is, dealing with time and cost, is how much does it cost per minute? If it costs the same per minute for each of these times, then we could say that it's proportional, that they have the same unit rate, the same cost per 1 minute. So to find cost per minute, we need to write this as cost divided by the number of minutes. So let's see what the cost is. If it were 15 cents for 5 minutes, that would give me a unit rate of 3 cents per 1 minute. If we change that cost to 24, but instead of 5 minutes, talk for 8 minutes, that is still 3 cents for every 1 minute. Let's check the others, because every single pair has to have the same unit rate for this to be proportional. And so far, so good. The last one is 72, and you can use a calculator to double check these. It does end up being 3 cents per minute, no matter how long you talk. And you could use the Desmos calculator just to double check these. It was 15, 24, 36, and 72. So you could come over here and type in 15 divided by 3, or divided by 5. 15 divided by I get this to go away. Put it on the keyboard. Okay, so 15 divided by 5 is 3. 24 divided by 8 is 3. 36 divided by 12 is 3. And 72 divided by 24 is also 3. Even if you did it the other way and you wanted to find out how many minutes you could talk per 1 cent, if you did 5 divided by, that would be 5 minutes per 15 cents is equivalent to a third of a minute per cent. You could talk for a third of a minute, or 20 seconds per cent. Even if you tried it this way, you'd get the same number each time. And since you get the same number each time, it is proportional. So again, this would be yes. A proportional relationship does exist. For the same reasons that one is the unit rate is constant through all the pairs of corresponding values on the ratio table. From what the information that we're given, this is proportional. Okay, and then we have the last one, which is Diani and Soliana. It looks like one is measuring rainfall in 5 days. The other one is measuring the amount of water wasted. And I can't tell, is that inches per year, or inches of water wasted? Okay. Well, I guess to tell if it's proportional or not, the ratio table could be helpful, but the graph tells you a lot. But just to double check, we'll look at both. All right, so maybe I can fit the calculator on the left side of the screen over here. Make this a little smaller. Okay, so let's just check really quickly. Does a proportional relationship exist using the methods that we have already used? So if one does exist, then 1 divided by 0 would be the same thing as 2 divided by 2, and that would be the same thing as 3 divided by 3/4. And that would be the same as 4 divided by 1/8. And 5 divided by 1. So they should all give me the same answer, which I got different answers for every one. Okay, let's look at the other one. If I divide 1 divided by 1/8, I get 8. If I do 2 divided by 1/4, I get 8. If I do 3 divided by 3/8, I get 8. If I do 4 divided by 2/4, I get 8. And if I do 5 divided by 5/8, I get 8 as well. I get the same thing every time I divide x by y. So the relationship between x and y is constant for this graph, and it is not constant for this graph. So it looks like for each day, the water wasted increases by 1/8 of an inch. Where here, the rainfall for each day, it rains a different amount each day. It doesn't rain the same amount each day. So I'm still not completely sure about this. I know that a proportional relationship makes a straight line with all of the points when you plot it. So there's no, and it goes through the point 0, 0. This one doesn't go through the point 0, 0, and I can't really connect the dots with a straight line. No matter what straight line I draw, I can't connect all the dots with it. I could go up, but that would miss those. I could go this way. I could probably hit almost 2 dots, but I can't draw one line and connect all of the dots like I could with that line. And this one doesn't go through the point 0, 0 either. And when I divided on the calculator to check for the unit rate, it was inconsistent for Dione, but gave me the same unit rate for Soliana. So I would go ahead and say that this graph is proportional and that this is non-proportional. That when I divided all these numbers, I did not get the same number each time. When I divided these numbers, I got the same number each time. And maybe it's the calculator that is tricky. So I'll show you exactly how you could do this. 5 dividing by a fraction is something new. So you could hit the divided sign, and then it gives you the second number. Their second number is a fraction. So you could enter it in like that. Or you could convert your fraction to a decimal and say 5/8 is equal to 0.625. So if you know that, you could do 5 divided by 0.625 and get the same answer. That this and this are equivalent. All right, well, I hope that helps you all. And if you have any questions, don't hesitate to ask.